instead of starting with numbers 1 and 2, let's start with the inequalities, because 1 and 2 are a review of equations, especially the special case equation. So let's start with 3, 4, 5, and 6, and then we'll go back and do 1 and 2. So looking at number 3, we want to get x by itself on one side. Where's the x at? Is it on the left side or the right side? Right side. I need to get it by itself, so I'm going to get rid of that minus 2 by doing the opposite, which is plus 2. That'll cancel out. That'll be 0, right? Now, what you do to one side, you must do to the other to maintain the balance. We are going to have 6. The inequality stays the same because you did not multiply or divide by a negative. The only time you ever flip that inequality symbol is if you multiply or divide by a negative. And right here we added 2, so that did not change. So this is your answer. However, we want to see the x on the left side and the number on the right side. So we just simply take what we have and flip it, right? So if it opened up originally to the 6, it has to continue opening up to the 6. So there's our absolute best answer. X is less than or equal to 6. And I might as well rewrite this answer in set notation. Remember, it's those little funky brackets. If we're dealing with the variable x, which we are, you write that down. You put the little wall right there, or the little line, and then you write down your answer after that little line. It's going to be x is less than or equal to 6. You close the bracket, and that's what we call set notation. Why am I writing that? Because I think I'm going to have some multiple choice questions on tomorrow's quiz. And the computer program that produces it writes everything in set notation. Okay, so make sure you understand that the answer that you have here is simply right in there after the line, just right there. Okay. Number 4. Now these are almost identical to the questions that you're going to see on tomorrow's quiz. Pretty easy, right? Yeah. So on number 4, let's get x by itself. Number 4, x is on the right side. Let's get rid of that 2. I am going to subtract 2 and subtract 2. My new inequality will be 2 take away 2 is 0. I didn't multiply or divide by a negative, I subtracted. So this stays exactly the same. The x comes down. Now that's my answer. However, I like to see my x on my left side and my number on my right side. So that's what I'm going to do. I'm going to write the x over here, the 0 over here, and the inequality has to also flip. If I took this 0 and this x and switched them, then this also has to switch when I write it down here. In other words, if it opened up to the 0, it has to continue opening up to the 0. So let's open up to the 0, and it's an or equal to. So there's our answer. Set notation, once again, funky little bracket, talking about x's, put that line, and then put the x is less than or equal to 0. Oh yeah, I almost forgot. One more thing that I could ask you to do on the quiz once you get your answer is to do what? Graph it on a number line, right? So just a quick sketch of this guy on a number line. 0 is in the middle because that's the number we're dealing with. Is it going to be a solid dot at 0 or an open dot? Solid. You put a solid dot right there. And this is going to the left or to the right? So this is to the left. So I'll put an arrow this way. Once again, if you want to use that little trick, it looks like, as long as you have your x on the left side, it looks like it's pointing to the left, so that's why your arrow goes to the left. Or it's as simple as this: x is less than or equal to 0. Less than is to the left, greater than is to the right. So keep all that in mind. Set notation, that's the way it's going to look like on those multiple choice ones. If I ask you to graph, you need to know whether it's a solid dot or open dot. If it has a solid line underneath it, it will be a solid dot. If it does not have a solid line underneath it, it's going to be an open dot. And left is when it's a less than, and you go right when it's a greater than. Moving on, number 5. Whoa. Number 5. Okay, so we want to solve this guy. What do I do first, Ivy? Multiply by? 3, okay. Brian, what would I do next? Multiply on the other side, also by 3. Okay, good. And then Janisa? What do I have left over? 2b. What about this guy right here? Negative 2b, right? Okay, so let's put negative 2b, and then what else? Greater than 12. You don't flip it, right? It stays the same. The only time you flip it is when you multiply or divide by a negative. Daniela, what would I do next? For my final step, actually. Divide by a negative 2. Divide by a negative 2. So, like we said, we're dividing by a negative. Vanessa, what does that mean when you divide by a negative? You flip the inequality symbol. So b is less than negative 6. And that's your answer. Set notation, funky bracket, b with the little wall, and then your answer, b is less than negative 6. Close that funky bracket. These are b's, not 6's. Yeah. Okay, and if I wanted to graph it, you go for a number line, quick sketch. You put your negative 6 right in the middle, and then to the left it gets more negative, and to the right it gets closer to 0. Now the question is it going to be an open dot or a closed dot at negative 6? Open. And is it going to the left or to the right? To the left. There we go. Covered all our bases on number 5. Let's move on to the last one, number 6. This one does require simplification. So let's combine the 5x with the minus 6x. I'm going to circle the 5x. I'm going to circle the minus 6x's, combining like terms. Right? You do this in your head. You don't show any work. It's just 5 take away 6, so it's going to be a negative 1. So we have negative 1 of those x's. And we also have the plus 3 that comes down, the inequality that comes down, and the 1 that comes down. So there's our new simplified inequality. We still need to get x by itself. So what do I do next? Anybody? Subtract 3. And when you do to one side, do to the other side. Brian, we're going to have a negative 1x greater than negative 2 left over. What do we do next?
You
divide by?
negative 1.
Divide by negative 1. All right. And when we divide by negative 1, what's our final answer? X is?
Does it change?
It changes less than 2. Now, why did it change? Because divided by a negative. Whenever you multiply or divide by a negative, on your last step, you have to flip that inequality symbol. Let's jump back to number 1 on this class opener. Number 1 and 2. Now, these are equations, but they're special kind of equations. They get really funky answers, those special cases that we dealt with in chapter 2. So on the left side of my first equation, I could simplify. What does simplify mean? Distributive property and combining like terms. There is distributive property over here. There's combining like terms over here. So on the left side, let me distribute 4 times x, I get 4x. 4 times negative 3, I get negative 12. There's nothing else to do on the left side. So I move on to the right side. On the right side, there is no distributive property, but there is combining like terms. Out of the 3 terms, the 2x minus 12 plus 2x, I could combine this 2x with that 2x, and I will get 4 total x's. And then I could bring down the minus 12. And of course, I'm going to bring down my equal sign. Now, at this point, you could stop doing what you're doing. Why is that? Because we have 4x minus 12 equals 4x minus 12. That's totally obvious, right? This is exactly the same as that, so there's an equal sign between it. When is that true? It's always true. So you could stop and say all real numbers. Now let's say you didn't see it right off the bat right there. Let's continue solving. You want to get x by itself on both sides, and you say I have an x over here, I have an x over here. I don't want x's on both sides, so I want to get rid of one of them. So let's say you decided to get rid of this 4x by subtracting it. And when you do to one side, you must do to the other, and it also cancels. So what do we end up with? We end up with negative 12 equals negative 12. When is that true? Always. Negative 12 always equals negative 12. Now, what does this really mean? It means that no matter what your x's are, look, our x's canceled out. So it doesn't matter if x is 5, if x is 20, or even if x is pi, or like negative square root of 7, right? All of those values, x could be any real number. So that's what we write on this equation, which was a special case. X equals all real numbers. Okay? Now on the other one, let's solve this thing. On the left side, I'm going to combine my x's. I have one x right here. I have another positive x right there. That's a total of two x's. I bring down the plus 2, bring down the equal. I'm going to distribute on the right side. I'll have 2x minus 2 right here. Now let's continue solving. I want to get x by itself. Here's one x, here's another x. I don't want x's on both sides. Let's get x by itself on one side. So I'm going to subtract this x, this 2x's. And what I do to one side, I do to the other, and it also cancels out. It also becomes 0. So I really have 2 equals negative 2. Now that, ladies and gentlemen, is what? It's impossible. 2 does not equal negative 2. So what do we say when it's impossible? We say no solution. Okay, so you could actually write it out, no solution, or you could write this symbol right here, the 0 with the line with the slash right through it. Okay, that means that it's impossible. You cannot find an answer for x that'll make it true. Okay, it kind of boils down to this over here. When you end up with something that's impossible, you say no solution. So like if you are working on an equation and you end up with the x's canceling out, you end up with 5 equals 10, or like 7 equals 2, or like 0 equals 4. That's impossible. What do we say? We say no solution. Now let's say when you end up with something that's always true, you say all real numbers. So like let's say you're working on an equation and the x's cancel out and you have 5 equals 5. That's always true. You say all real numbers. Okay. Now on the no solution one, you could again use your symbol, or on the all real numbers one, you could again use your symbol. Okay. So I hope that helps. What I want to do now is move on to these special case inequalities. So let's go over these special case inequalities, not equations. Number one, let's zoom in and distribute, or zoom in and simplify. So on the left side, I'm going to distribute negative 2 times 8x, that's negative 16x. Negative 2 times 4, that's negative 8. And then I'm going to bring down the inequality, and I'm going to distribute on the right side. Negative 8 times 2x is negative 16x. And negative 8 times positive 5 is negative 40. So let's continue solving the way we would solve the equation. What do? We want to get x's by itself. We have an x here and an x over here. You want to get x's by itself on one side. So let me get rid of the negative 16x by adding 16x. And what I do to one side, I do to the other. And again, the weirdness happens here where the x's also cancel. So what's left over? We have a negative 8 is less than negative 40. Now, what do you guys think about this? Negative 8 is less than negative 40. Is that a truth? Is that always true? Or is that false? That's impossible. False. Negative 8 is not less than negative 40. Now, you might need like a little visual, right? If you think about the number line, here's 0, here's 1, here's 2, and negative 8 is going to be right here somewhere, but negative 40 is going to be like way over here. So which one is further right? Well, the negative 8 is further right. The negative 40 is further left, which means that negative 40 is less than negative 8, or negative 8 is greater than negative 40. Now right here it's opening up to the negative 40. So this is saying that negative 40 is greater than negative 8. That's false. Negative 8 is greater than negative 40 because it's closer to the positives. So since we know this is impossible, what do we say our answer is? No solution, right? No solution because it's impossible. Or you could just put this symbol, bam, because this guy is impossible. Negative 8 is not less than negative 40. Negative 8 is greater than negative 40. Let's check out this other one over here. Let's go a little quicker here. Let me combine like terms on the left. So my 3x, combine it with my x. That's a total of 4x's. Let me bring down the minus 2. And on the right side, I'm going to take that 2 and distribute. 2 times 2 is 4x. 2 times negative 3 is negative 6. Let's bring down that inequality. And let's continue solving. Let's get x by itself on one side. I'm going to subtract 4x. Subtract 4x. It also cancels. What do I have left? I have negative 2 is greater than or equal to negative 6. Is that always true or is that always false? That's always true, because negative 2 compared to negative 6 on a number line is greater than. So here's a number line. If I put a dot at -2 and I put a dot at -6, which one's on the right? The -6 or the -2? The -2 is on the right. That means that -2 is greater. So here's -2. It's definitely greater. That's a true statement. So when is this true? It's always true. So what do we say? All real numbers. Okay, all real numbers. So here are the notes once again. When you end up with something that's impossible, you say no solution. When you end up with something that's always true, you say all real numbers. Let's jump to this one right here. Like I said, there will be some multiple choice questions on tomorrow's quiz. Right here we have the inequality 3n is less than or equal to 5. Now the question is, which one of these following possible answers can represent it? Okay, so what do you guys think of option A? 3 times a number is less than 5. Is that the answer? Why not? Isn't that a less than symbol? That's a less than. Less than or equal to, right? So I needed the word or equal to, so option A cannot be it. Let's get that out of there. How about B? The product. What does product mean? Times, okay. So the product of 3 and n, okay, 3 times n, that's great so far, is no less than 5. If it said is less than or equal to 5, yeah. But it says is no less than. That's a little confusing. No less than actually means greater than or equal to. Okay, and I actually made a video for you guys to understand that in a little bit. So yeah, this one cannot be it because it doesn't say less than or equal to. So let's get that out of the way. How about option C? 3 times a number is at most 5. 3 times a number is at most 5. That is correct. That's your answer. Okay. Now, why is that? Well, 3 times a number, it's right there, is at most 5. You need to think about that. At most 5. What does that mean? If I say, let's say I tell my son, yeah, clean the backyard, and he tells me how much are you going to pay me, and I say at most $5, right? That means that it could be 5, or I could pay him $4, right? Or 3 or 2, right? But at most is the max. So yeah, that really means less than or equal to. Okay. And if you go to option D, 3 times the number is less than or equal to 6. No, because that's a 5 and it should be, that's not a 6. And the last one, the sum of 3 and n is no more than 5. Well, that's not the sum, that's multiplication. So the only possible answer here is C. I hope this video helps you guys get better prepared for tomorrow's quiz. Yeah, that's it.